Hello everyone and welcome to the fourth Winter Data and AI Meetup. Thank you for joining us today. My name is Andrei and I will be hosting this event today. And our next session is about building scalable and reliable data pipelines in BigQuery using Dataform. Our speaker is Iuliia Kaymak, a senior data analyst at EPAM Turkey. In this talk, you will learn how to design clean and tested data pipelines, organize data into clear layers, and improve data quality using modern analytics engineering practices. You will also see a practical demo of how Dataform works with BigQuery. If you enjoyed this event, please like and subscribe to support our community. Your feedback helps us improve future meetups. If you have questions, please write them in the chat and we will discuss them at the end of this talk. And now let's welcome our speaker, Iuliia. The floor is yours.
Thank you, Andrei. Hi, everyone. Thank you for joining today's session. I'm really honored to have a demo at the Winter Data and AI Meetup, and the first day is smoothly coming to an end. So please feel free to look at the old Winter Data and AI Meetup. Please feel free to check all the agenda and register to other demos. But now here today we are going to talk about Dataform. So yeah, let's get started. You already listened to the small introduction from Andrei about me. Yes, I'm a senior data analyst. If you find my name challenging for spelling, you can just call me Iuliia. You can see how you can also spell it. I am based in Turkey now. This in city of Bursa. The city is pretty close to Istanbul, and I have 7 years of experience in data analytics and visualization. It all started from Microsoft Excel with writing functions and macros, pivot tables. Yeah, that's it. But during the time of my learning on my career path, I also gained some knowledge in Power BI, in dbt, Google Cloud Platform, and AWS. I have analytical background in FMCG company, in supply chain department, in a pharmaceutical company, and also as a member of a development team developing the web application. Our agenda for today is the following. We will start with a smooth introduction of a data form. We will also take a look at the comparison of data form and dbt. If you already have some background in dbt, it will be also the good point for you to know. And the main part, as Andrei already mentioned, it will be the demo, the crucial part of today's session. It will be the live demo where I will share the live project, the live Google Cloud project, and I will show you how Dataform works in practice. And wrapping up our sessions after the demo, I will provide you with the key takeaways and best practices so you can apply it in your real life projects, and we will have some time for Q&A session. Okay, let's go to the smooth introduction. Companies now scale their data operations. Many of the companies, they are adopting BigQuery as their primary data warehouse. BigQuery is widely used because it scales easily and removes infrastructure overhead. With this shift, data teams are expected to deliver reliable, scalable, transparent, and well-governed analytics, not just only SQL query. And this reflects a global trend toward cloud-based data platform. But as data grows, managing analytics with just SQL alone becomes challenging. That's why tools like Dataform are essential. For today's session, my goal is to give you a high-level introduction to Dataform and its core capabilities. We will also cover the key concepts, practical takeaways, and some best practices you can apply in your real project. The main part will be the live demo. And finally, apart from the Q&A session, I will also share you the slide where you can find the learning resources. By the way, the presentation will be shared afterwards to all the users, so you can click the links provided there in the slide with useful resources so you can get started with Dataform. What is Dataform? Dataform is a cloud-based platform that helps data teams build, control, and orchestrate SQL workflows in BigQuery. This picture you see now on the slide is taken from the Google Cloud blog, and to my mind, this shows pretty clear where BigQuery and Dataform appear in the whole data chain. So this gray area you see is the BigQuery zone. In BigQuery, we store data. In our today's session, we do not cover the ways how data appears in BigQuery, right? Let's take it as an input. we have raw data already stored in BigQuery. The blue zone is the area where Dataform steps in. With Dataform, we are able to take the raw data and build controlled, transparent, reliable pipelines. As a result, we get transformed models that will be further used for reporting, analytics, AI agents, etc. Dataform lets you manage data transformations in ELT process for data integration. In Dataform, you create repositories to manage your code. These repositories support version control. You can link a Dataform repository to a third-party Git provider. You can then create multiple development workspaces inside the repository, or simply speaking, you can create multiple branches so every data analyst or data engineer can first securely work on their code in development, test it, and only then push it to the main or master branch. Dataform compiles your code into a workflow of standard SQL. As a developer, you don't need to care about correct DDL statements. This is on Dataform. You can also use JavaScript while building your models, and they will be finally compiled into SQL. Dataform resolves dependencies and checks for errors, including missing or circular dependencies. It also builds for you the dependency tree of all actions to be run in BigQuery. So it ensures traceability and can really help data analysts and engineers to follow upstream and downstream dependencies, or simply speaking, to follow parent and child dependencies between your data models. Some of you already think, especially who have experience with dbt, that Dataform is just a copycat of dbt. Generally speaking, they both are SQL-based data transformation tools. They both do the same thing under the hood. They run and orchestrate SQL commands in underlying databases. In the center of the slide, you can see the biggest rectangle where I put the common characteristics of both dbt and Dataform. They both treat transformations as code and build dependencies. They support modular models, documentation, data quality. They enable analytics engineering best practices. For example, they both follow don't repeat yourself approach. They approach when you once write macros or function variables that can be then reused at any stage by any of the developer. Another example of this don't repeat yourself another example of the best practices that they both support version control. And they both are designed to build analytics ready data set in the warehouse. But for sure, there are some moments where they differ. First of all, Dataform is natively integrated with BigQuery, and this could be critical if you have data stored in many other cloud services, not only BigQuery, but Redshift, Athena, etc. dbt in these terms is more universal, hence more complex. It requires project setup and environment management. While Dataform is limited to work only within BigQuery and doesn't require sophisticated setup, that makes it easy to use even for non-technical users. So probably it's a good point to start with this data orchestration tool, while at the same time, dbt requires more technical knowledge. The key difference in data modeling: Dataform uses .sqlx file extension, while dbt is using .sql extension file extension, and Dataform uses JavaScript as its scripting language. At the same time, dbt opts for Jinja. Jinja is a Python-based templating engine. Talking about costs and other expenses, Dataform does not generate additional costs itself. There are only standard Google Cloud charges. At the same time, dbt platform you could probably also hear before it was named as dbt Cloud. Now it's named dbt Platform. So dbt Platform works on monthly subscriptions plus data platform charges. dbt Core is more efficient in this case, but it requires more technical knowledge to set up and maintain. Summing up all the common characteristics and peculiarities of these data tools, we can conclude that if your data is BigQuery oriented, it can be a good idea to use Dataform. But if you're working with multiple data platforms and you want to cover all of them in your data project, then you would better choose dbt. Now we are getting closer to a demo, and before we started, let me give you a bit of context. I have prepared a use case pretending that I'm a data analyst at a company selling bikes and other stuff related to them. And at the initial state, I know that commercial data is stored in BigQuery. You can see in the screenshot that the tables are on the raw data set, and there are tables like fact sales, discounts, prices, locations. For sure, in 99% of cases, you will not see so few models of commercial data in real life, but for educational purposes, I think it's sufficient. In this slide, you can see the schema of tables and how their relationship look. Pretty limited data schema, but it's essential. We don't need more today. You can also notice dimension tables like SKU, employees, locations, cities, countries, regions, and for some of them, I put pink frames inside, highlighting that these dimensions are changing, and we will need this information in the demo. So let me switch to the Google Cloud project. Yeah, here it is. My Google Cloud project. You can see that I have this raw data set and some tables there. How you can find the Dataform. Dataform can be easily found in the BigQuery drawer. So you will see Dataform. Let's go there. In the new window, you will see how many repositories you have and their locations, also sources. As I mentioned before, Dataform repositories can be linked to the GitHub or GitLab, for example. So here you can see that, yeah, there is a connection, there is a link, and the status is valid. So we are good to go. We are good to start working. If I go into the repository, I will be readdressed to another window where I have my development workspaces. What is the development workspaces? If I try to make this comparison, if repository Dataform is equal to the repository in GitHub, so here, if you have development workspace in the Dataform repository, it's equal to the branch in the GitHub repository. So here is where you can create your development workspace. Then you take the latest state of your main branch, because here the default branch is main. Developer creates a development workspace, then can start works after commits changes and pushes into GitHub. So here in my demo, I have created development workspace named dev. So I can go there and check what we have done inside. When you first initialize your project, you will see that you will have two folders, definitions and includes. Definitions is the folder where your data models will be stored. Includes is the folder where you can store the helpers. They can really help you build efficient code. You can write JavaScript functions. You can put variables there. So this is what you see in the time when you first initialize. But here, if I start with the definitions, you can see that I have created by myself these four folders. And let me start describing the way how it can work. So this is only my vision. You will not see this when you first initialize the project. So first of all, we will start with the sources. We need to declare our data sources to Dataform, so this way we can make them visible to Dataform. So here in the sources, you can see that the JavaScript file, and if I go there, I will see that I declared my data sources. We see the project, we see the raw data set, and we see cities table, right? Countries table, discounts table. So you can declare all of the sources within the same file. Then, when you declare the source, you can go to the staging level. Staging layer is the layer where you can create the view of your sources that should be pretty close, as much as possible, close to the original data source, but you can do low-level transformations there. So for example, if I go to the staging cities, you will see the structure of how this model can be built. And also, take a look at the file extension .sqlx. So if we look at the file, what do we see? Let me make it a bit bigger for better view. Yeah. So the first part is the config. The config part is the place where we can define which materialization type of our model will be. So here I have view, but it's possible to change it to the table, to incremental table. We will not cover it for today, but yeah, it's also possible to change it. Schema is the data set where I want my model to be created. Tagging, also important part, we will talk about it a little bit later. Assertions in the language of Dataform, it means data quality check. We will also talk about that. But after you completed the config, you can see the part of the SQL code, but you see the strange ref here. What is the ref? Ref is the function that actually finally helps us to build the dependency tree or graph, compiled graph. And if I already previously declared cities in a data source, yeah, in this table, in this file, here using the function ref, I set the dependency. So this is the model that is a child of the sources I previously declared. And if I go to the tab compiled queries, yeah, this is an assertion, yeah, this one, because this is the model we are creating, right? So you can see how the ref function is compiled into SQL. So having this ref function and following the names within your Dataform repository, you can easily track the dependencies in your project. Also, the metadata tab is the one thing that I want to show you. Staging cities, the model. In this tab, you can see where your model will be saved. You will see which type of it, you see tagging, and important thing, you will see dependencies. So this is how ref function really help us at this step. So we see dependencies, it means the parents. So yeah, right. And we see dependents, we see children of the model. Assertions, data quality checks, they are technically speaking the children of the of this staging model. But about assertions we will talk later. Let's take a look at the other example. The other example of staging model is countries. Now we see more interesting SQL code here, right? So yeah, we have here the same config, and we can also see some functions, and we don't understand what does actually happen here. So the answer is that here I'm using the function that I have written by myself. And this function is stored in this includes folder where I mentioned that this is a folder of helpers. So if I go to the functions file and if I check the function in the JavaScript, written in the language of JavaScript. So we can see the function, we can see which inputs it has right here. Ref table, timestamp column, partition columns. Yeah, some constant variables declaration here, and what is returning. What this function returns? Actually returns the piece of SQL code. So yeah, pretty understand what does it do. It takes all the columns from ref table and generates me row valid from, row valid to, and is active. And if I go back to the countries, we see that this is the step in this CTE where I'm generating this column based on the inputs I provided here. And let's take a look how compiled query looks like. Staging countries, and we will see how it compiles into SQL. Yeah, raw data using still again the ref functions. We see it's compiling into SQL with the full address, with the full ID of a table, and how this function add SCD columns compiles into SQL as well. All right, then also I would like to show you one more thing. While you are working with your SQL code, you want to be sure during your development, or you want to have a possibility to look what does your code actually do during your development. Because okay, writing the SQL code, but how can you test it? How you can check that is something that you really expect? So here you can have the run button. Run button, and as a tooltip says us, it's the way how you can preview your results. So if I click on run, I'm seeing that this columns, they are coming from the original countries table, and these columns that are generated. And yeah, this is the expected behavior is active. In this column, I expect to get just zeros or one, and yeah, logically it's consistent. So yeah, it's pretty good what I wanted to see. Important thing to know that when you run your preview, it means that you just preview in your workspace. You will not see the staging countries model actually created in your Google Cloud project. If you want to run it, you better start execution. Start execution also is identical to run the job, right? So you are running the job of execution the model. So here in start execution, I'm selecting actions. You can also see that there's a possibility to choose tags. So yeah, this is the short answer why you need to apply tagging in your configuration. But we are starting with just staging countries. I'm starting my execution. In the pop-up window, yeah, we see that this is successful. It just took 2 seconds to do that. And what's happening here? Here you can see the full code that builds your actually model. Do you remember in the previous part I said you that you as a developer, you don't need to care about DDL statements because all of this part is Dataform. Dataform takes on itself. We are just responsible for providing this SQL code. This is actually the SQL code that we saw in the .sqlx file. All right, let me come back. Okay, so this is the difference between run and start execution. And by the way, in the start execution, one more thing I wanted to show you. You can see the action destination. You now see that your model is created in the project, and this is the ID, the path of the model, staging underscore dev, because dev is my development workspace. It's not the production. It's not the production version. Now let's take a look at the assertions. Here in the assertions, 1 second, I have some technical problem. Yeah, all right. Yeah, now it's better. All right, talking about assertions, we need to say that in a simple, understandable language, it means data quality check. So data quality check is divided into 2 main groups. The first group is a general data quality check, and the second group is a singular data quality check. So general data quality check, built-in data quality check, and examples of this generic data quality assertions you can see here in the config. So in the first data quality, I'm ensuring that my country ID, country code, and region code, they are not null. Then I'm checking for uniqueness, yeah, the kind of the primary key of my table. And raw conditions, I'm checking the logic, I'm checking the model for the logical, for the consistency, right? But let's go to the singular assertions. So yeah, generic assertions can be written this way. There are a limited number of such assertions, but it's really well described in the official Google documentation, and we will not take too much time on that. But what if we want to create a more specific specific data quality checks, right? That is not kind of generic. Here is where assertions folder steps into our chain. And for example, here in our cities model, I want to be sure that in my cities table, I have country ID, and I want to be sure that this country ID is valid, and these values really exist in the other staging countries dimension. And still here we have the function that I'm really using, and in the compiled version you can see how the code is compiling, how it's checking. And let me still run the preview. there's no data to display, it means that the data quality check is successful. So we have nothing here. We have no rows that really break the logic that we expect. So this is an expected. This is a good result. But what happens with Dataform if we see that data quality check is failing? I have prepared one example. Just let me quickly show it. I have prepared one example. What if in the table of cities I insert the value with the country ID 99, but we don't have this 99 ID in the country's dimension. So what's happening there? I'm going to this assertion. I'm starting my execution. I also include dependencies, means that I'm including the parent dependencies. Starting the execution. And let's take a look at the result. We see that it's failed. And we still see which exact view is failing, and we can see the details. So yeah, the query error assertion failed. We expected 0 rows, but we now have invalid value in country ID there. If I'm changing it back, and if I delete this row with invalid country ID, let me just rerun this job. Yeah, I will still execute it. Include dependencies, start execution, and let's see what it returns. Now it's successful. Yeah, right. So now we saw what's happening if the data quality check is failing. Yeah, that's good to know, and sometimes it really helps to faster find what data quality check is failing, what the parent dependencies, child dependencies. So yeah, it's good to understand the scale of the problem. Then the next part I'm going is the marts part. The marts part is the folder where I created BI ready models. So for example, in our staging folders, we see that we have cities, countries, locations, regions. So now there's an idea to create a general table that's joining all the information into a single hierarchy. So here's the geolocations coming into the place, and you can see the SQL code. Yeah, many CTEs, but the logic is pretty simple. They are just joining and joining, and finally we can see the results. We can see the results as a combined view of all the locations we have, and like supporting their geographical hierarchy of the company. And you also see that in the list of marts, I have geolocations enriched file. What's the difference between them? In this enriched file, I'm generating the new column. And what is the syntax here of what I'm using for this generation? So it's also understandable from the previous examples that I'm using the function. But what is that, and what is this block actually means? This is the block where you can declare your variables, when you can retrieve any variables you have already mentioned in your repository, or you can retrieve the functions that you already written and paste in any part of your repository. So what is the key countries, and what does this require? Having this code, I am actually getting the list of key countries that I have in this file that I have previously declared. So here's the logic. For example, my CEO is coming to all the data analytics team and saying that since now these 3 countries, they are considered to be key. And we need to also reflect this information in our geography hierarchy, right? Commercial hierarchy. So this is the way how it can be actually realized. So you can create a variable, and this variable can be reused by any of the developer in other models, for example. So reuse the things. Going here, I'm also getting this variable from this vars file, and I'm using this variable in a function. And finally, if I run the preview, I see that my is-key country column is generated. We can see zeros and ones where we actually expect it to have to be. So yeah, this is how also it can be organized. Also, after that, while we were working with geography, with the hierarchy, I would like to show you one more thing. It also can be useful. This is a compiled graph, or so-called dependency tree that I've mentioned in the first part, right? The Dataform is able to build the dependency tree. So here you can see the full compiled graph, and from left to the right we see how the data is interconnected, and we can easily follow the dependencies downstream and upstream. So it starts with the source declarations. Yeah, let me make it bigger. We can start with sources declarations after staging models. Assertions, they are technically views, so they are also appearing here. Locations enriched, and yeah, that's pretty that's pretty clear. We can follow the whole path of our models, and how tagging can be used here. So for example, here in the compiled graph in this tree, I want to filter out the other models and leave only those that have this tagging. So yeah, we can easily focus to some specific part, right? Because it's just in our pretty limited model, we can see that it's easy to get lost in this dependency tree. But if you are using tagging, if you are applying it in a smart way, you can also support this kind of smart filtering. So you can track the dependencies there. All right, and now there is one folder that is actually left, but okay, I have my staging models, I have data quality, I have data marts, but what if I'm a data analyst and I want to create a, for example, a Power BI or any other report about sales, for example, because we have sales as a key metric here. All right, so what I can actually do, I can create the repository. I'm creating the folder, and I have already prepared the SQL code. Let me just copy and paste it. So in analytics folder, I am creating one more folder. So this will be the name, probably the name of my future Power BI dashboard. So yeah, it can be structured this way. And inside this sales performance folder, let me just create a file that will create finally a view that I can use for my Power BI reporting. Important to keep .SQLX extension here. I'm creating the file. You can also see that there is a change because it's getting your latest version of the main branch, of the production branch, and here is your change, and afterwards we can easily commit our changes here. So this is the view that I actually need. Yeah, type view, schema analytics, tagging. Let me run the preview. Let me just be sure that this is what I really want. Yeah, pretty clear and understandable structure. Query is compiled. There is no red signs, so it's also can be helpful if, for example, if I initially do some mistake, we can see that there is an error, and it's also a good helper for you. But let me just return it back. It's recompiling. Everything is green. Yeah, so good. If I go back to my project and look at the structure of the data sets that we have. So raw data set is the data set where we have our initial table stored, and afterwards assertion. This means the production. Assertions def means the assertion of my development branch, marts of development branch, staging development branch. But now there is no analytics underscore def data set. And if I start the execution, and if I refresh the contents, yeah, I can see analytics dev dataset appeared. I have my view there, so I can try to maybe in the development part of the task to create some simple visuals in Power BI reports, like to play around with that to retrieve the data from the dev. But yeah, we ensure that this is what we actually expect. So let us commit the change. Edit view for sales Power BI report. Yeah, commit message, commit all files. We can push to remote branch. It means that we are pushing it into the Git. Yeah, and it also give us a link that's redirecting us to the GitHub. We can create pull request. We see the changes. Yeah, everything looks fine. Yeah, create the pull request. No conflict with the default branch. Pretty good. We are free to merge it as it is. Yeah, pull request successfully merged. Yeah, and we can see that we have already did the change. So what we can do next, we can go to our project, we can refresh the content. But why just analytics dataset is not appearing here? Because the short answer, once you have just GitHub to operate, to manage your code, it doesn't mean that your full run or any job will be started. You need to handle it. And right now I'm going to show you how to do that. You go out from the dev workspace to the whole Dataform project. You can go to releases and scheduling. Here you can create any jobs. You can set up the jobs with any schedule you want. So it can be 2 times per day, it can be 2 times per week, or probably it can be manually triggered. For example, here I have just weekly Sunday release and weekly Sunday full run that is based on this release. So what I'm doing next, I go to release. I see that my last compilation has taken place in 22nd February. So now let me, based on the latest version of the main branch, to compile it. So now I have the fresh version of the code. And let me just run my full run here. There is the details. So you can see the whole job. Now let me refresh. Yeah, pretty good. Everything is successful. So let's go back to our Google Cloud project, refresh the content, and we can see that, yeah, analytics, default analytics dataset appeared here with our views. In this case, we have just one view, but okay, with just view that we have just created. So yeah, we can easily use it in our production analytics. So this is actually what I wanted to show you. So let me just quickly switch back to the presentation because we have some slides left. This is where we stopped in. Okay, in this slide, I just want to give you a short overview what you have just seen. The main idea of the slide is that to give you an understandable explanations of what definitions folder makes and includes folder. So definitions answers the question of what data models you want to build, and includes is the place where you can create your variables, create your reusable functions, and this answers the question of how you can build your code. The key takeaways from the demo. So Dataform. Dataform enables analytics engineering directly in BigQuery. Well-structured project improves scalability and maintainability. So in the vision in the vision that I've provided in the demo, is probably the way how you can start organizing your work. Start with staging, then start with marts, and the latest part can be an analytics layer. Data quality checks also impossible to also necessary to be created, and data quality should be built in, not added later. This is a common mistake. Like, I will put this data quality part in the backlog, but probably it's better to do it at the time of a development, because in most cases this backlog always is postponed and data quality really not stepped in. So this data quality should be built in. Git-based workflows support collaboration and governance, so multiple data engineers and data analysts can work independently. If you just want to, like, short disclaimer, if you want to play around with Dataform and to study how it works, probably you will need a billing account if you would like to link your GitHub or GitLab repository with your Dataform. And we need to have an ultimate goal. BI-ready models are the final product. So we are creating staging models, not because just we want to create staging models itself. No, we create staging models, then we create marts, then we create analytics views. So we have the full cycle of data moves. Best practices: use clear layer separation, keep staging models simple and close to the sources, design models with the BI consumer in mind, write assertions or write data quality checks for critical business rules. We didn't cover it for today, but it's possible to set up Google Cloud alerts to notify you when something is going wrong. There is a workflow failure or any data quality checks failure. Leverage Git branching and version controlling. Apply tagging to models. Use compiled graph to see the dependencies. Apply don't repeat yourself approach that I was mentioned previously in the first part. The useful links is here. The first and foremost, the Google Docs documentation, and all the other useful articles, and even YouTube video, YouTube and other demos, so you can also take a look there and see what's also possible to implement in Dataform there. So this is all from me for today. I'm ready to answer your questions. I saw there are already some in the chat. I just briefly show it. So yeah, I'm ready to answer your questions.
Thank you, Iuliia, for this amazing presentation and the demo. Yeah, we've got a lot of questions, and we will try to answer most of them. But for our attendees, if your question will not be answered during this session, please post it as a comment to the event page, and Iuliia will answer it in text a bit later. So let's start with the first question. Is Dataform for transformations only? Can you use it for extract and load data?
Dataform for data transformation. So as I mentioned in the first part, we take as an input that we already have data stored in Dataform. So yeah, mostly it's about data transformation. It's about building the pipeline and building data quality checks. So yeah, the short answer for transformations.
Yeah, and the next question is very similar to the first one, but it's repressed a bit. What is the place of Dataform in the data warehouse, data lake development? Like, is it for core or presentation or orchestration?
I think I didn't get that question. But the place of the data form, if you just let me to come back to the previous slide, maybe it would be better to show you this way. So once again, after you see demo, maybe it's now will be clear. But let me try to explain. The data form. The data form is coming after we have already ingested tables in the BigQuery, and it's possible within data form to build SQL pipelines, version controlling the code, and deploy our pipelines. So this is where actually data form steps in, and what are the possibilities of data form within BigQuery.
Hmm. Yeah, I think it relates to mostly to core for
Mhm.
this question. So thank you. The next one, what do you mean by model in context of data form? What is model in data form? Because it's a
Model.
common term.
Yeah. Model in terms of data form means that did you see in the demo that there is a .sqlx file that where I created any table or view? So this is this is called the model in the data form. So the entity you create for your Google Cloud project using the data form.
The next one is about building BigQuery features. Can Dataform use partitioning, clustering, and other features available in BigQuery?
Yeah, partitioning, clustering, they both are possible to implement. We didn't cover it for today, and yeah, I also didn't mention it, but thank you for the question. Really, really good one. Yeah, partitioning is possible, clustering is possible. Also, it's possible to create an incremental model inside the data form. So, and all of these types of models, okay, types of models are really well written, very well described in official Google documentation. You can see the examples. You can also check the other references. So yeah, it's well written there.
Mhm. Great. So next one is what is the tool you use to trigger the data form sequence of transformations? Like, do you have an orchestrator for it, or it's built in data form?
It's built in the data form, and this part is the part where I showed you how your release and workflow configuration steps in, and the example with the weekly Sunday full run. So this is actually how you can create jobs, how you can schedule it. Also, it's possible to separate different kinds of jobs. So, for example, if I have some incremental models, but it's a best practice, for example, once in a week or once in 2 weeks, for example, to do the full run, the full refresh. It's also the parameter that can be described when you just want to set up your schedule. So it's a built-in part.
Great. So we don't need any other tools. This one
Yeah.
only.
Yeah.
Uh, and what happens when an assertion check fails? Does it cause the entire data load to fail, or skip the incorrect row only, or place incorrect rows somewhere?
Mhm. Yeah, also pretty good question. What happens when we have the assertion? Assertion, I think I mentioned it in the presentation. Assertion technically is a view that's created based on the code you provided. So, if, for example, I have my cities dimension and I have any data quality check that's failing, in this case, the staging model is still building, and the view of assertion turns red when you go to the to the execution, and you see the records of what was built and what the status of build, so successful or fail. So the model itself is built, but the assertion is failing. So entire data is not failed. And as I see and I remember, skip the incorrect row, no, it's also not happening. It doesn't skip any incorrect rows, or place the incorrect row somewhere else. It also is not happening. So the parent data model is not failing just assertion, failing just data quality check.
But
I hope I could answer the question.
But if those invalid rows are not skipped, how they will be propagated to the target? It's not clear.
Well, if you have in your raw data, if you have some value that actually is not what we expect, for example, and if you have the other models, for example, you have the staging, you have marts, you have in analytics, you have some views that you finally use in your reporting part. So if data quality check is failing, it doesn't mean that all your pipeline is failing. So the models will be created, the models will be built. But when you see that the data quality assertion is failing, you will be notified about this, and you can start your investigation, what is happening actually there. It's also, if it's needed, it's also possible to, for example, filter out this kind of rows.
Okay, they will be labeled somehow, so we can filter them and then decide what to do with those rows.
Yeah.
Right?
Yeah. When assertion is failing, you will see as a parameter the number of rows, and you see the invalid key or invalid row. So you can see all the rows that are actually failing, and then the action is needed. So how you're gonna handle these wrong values.
Yeah, got it. Thank you. And maybe the last question: when processing large tables using CTs may lead to memory issues. Can we use temporary or permanent tables instead of CTs in that case?
Yeah, temporary table is also able to use. It's possible. I mean, there is no technical limitation of it. In terms of other good practices, how to prevent any memory issues, especially if you are dealing with really large data models. So the good point is to create clustered or partition models, and this way you will use less memory. And if it's needed, also it's possible to make the model incremental. Yeah. So this is also the way how we can deal with the memory issues, how we can prevent them.
So we run out of time. That concludes this session. Thank you all for joining us, and if you still have questions, please post them to the event page and Iuliia will answer them in text. And please leave your feedback using the link in the description, where you can give speaker a thank you page, rate this talk, and download the presentation. Thank you, Iuliia. Thank you for this great talk and amazing demo.
Yeah, thank you,
Bye-bye.
everyone. Thank you, everyone. Wish you good luck with the Dataform. I hope the session was useful to you. Yeah, thank you, and have a good day ahead. Bye bye.
Bye bye.